and b not equal to 1. So b could be 2, 3, 4, 5, any of the numbers in between. The logarithm of y with base b is denoted log base b of y, and it's defined this way. Log base b of y equals x if and only if b to the x equals y. So things to pay attention to. I'm going to zoom in a little bit. This b is the same base as that b. Okay, so the base of the log is the base of the exponential. And our y in this number is the same as the y in this number. And then here's the major thing for today. Our logs are going to equal our exponents. So this x is the same as our exponent. So I'm going to say this over and over today. Logs equal exponents. So the first thing that we're going to do is just rewrite a whole bunch of logs and exponentials so we can see that they're really just a way to rewrite one another. It's like you're translating from one language into another. So I've got all of these logarithmic functions, and I want to translate into my exponential form. Keeping in mind this, log base b of y equals x if and only if b to the x equals y. So log base 2 of 32, that's how you read it. So you say log and then the base and then of our number is equal to 5. The way that we write this in exponential form is our b and our b have to be the same. So look again up here. So 2 is our base, so that's going to be our base of our exponential. And then one of my numbers, 32 or 5, has to be the exponent, and 1 has to be the number that it's equal to. The argument is what we call it. And we know, or what I just told you guys, is that our logs equal our exponent. So the thing on the other side of the equal sign is always going to be the exponent. So exponent is 5, and then the number that's left is 32. If you think about if this makes sense, 2 to the 5th, plug that in your calculator, or think 2 times 2 times 2 times 2 times 2 is in fact 32. So if this is a true statement, then this should also be a true statement. So that's a way to check yourself when you're done with each of these problems. The next one, how I read it, is log base 5. Notice that the 5 is small, of 1, which is the argument, equals 0. So my base has to be the same in my log and my exponential. So our base is 5, our base is 5. Logs equal exponents. So my exponent is 0 equals 1. So notice I'm just rewriting exactly the same way as I had it above. The next one, log base 10 of 10 equals 1. My base is 10. Logs equal exponents, so that's 10 to the first, is equal to 10. Does that work? Yeah, 10 to the first is indeed 10. 10, or log base 10 of 0.1 equals negative 1. I can rewrite this, keep the base the same, so my base is 10. My exponent, logs equal exponents, so I get negative 1. And then the last thing is what it's equal to. Think about if that makes sense. 10 to the negative 1 is 10, but I've got to flip it because of the negative power. 1 over 10 is 0.1. And the last one, log base 1/2 of 2 equals negative 1. So their base is 1/2. Logs equal exponents to the negative 1 equals 2. Remember again what a negative power does. It flips our number. So we've got 1/2 to the negative 1 is 2. This is going to take some practice, but once you kind of get in the groove, it's just like putting together a puzzle. You take the initial, you rearrange it in a particular way, and that is the definition of a logarithm that's related with an exponential. Here's some special logarithms. Logarithm of 1. So I have log base b. B can be any number here. So b is any base. Log base b of 1 equals 0. This is always true because I can rewrite this as our base Logs equal exponents, so my power is 0. And 1, this is always true for any number. So if b is 2 or 3 or 100 or a million, anything to the 0 power equals 1. Okay. The next one is log base b of b equals 1 because b to the first is 1. So again, b is our base, so that's this piece. Logs equal exponents, so that's our exponent. And then b is our number, or our argument is the mathy way to say it. So this is going to be true whether b is 2 or 3 or 4 or 5. 2 to the first is 2, 100 to the first is 100, 5 to the first is 5. So any number that I plug in there will indeed work. The next thing we're going to do is we're going to evaluate this expression. So what power of b gives us y is how they kind of want us to think of it. I'm going to write it like this. I've got log base 3 of 81, and I want to know what that is. So I'm going to say, okay, that's going to equal something. I don't know what. So what can I write down? I know that my base has to be the same as my base, and then logs equal exponents. So my exponent is that question mark. I don't know what it is. So 3 to what power equals 81? I can try some stuff. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. So my question mark is equal to 4. In other words, I can write this as log base 3 of 81 equals 4. So what you're really doing is you're saying, what is that exponent that makes our logarithm? So number 2, it's like, what is the exponent? 3 to what power gives me 9? You can already probably think of what that is, but I'll rewrite it again. So log base 3 of 9 is question mark. I don't know what it is. Base matches base. Logs equal exponents. So logs equal question mark. Exponent is question mark. And then what's left over is our 9. So 3 to what power equals 9? That is the number 2. You can write these answers just as numbers, so like 2 or 4 or 1/2, whatever the answer is. You don't have to write like x equals 2 or x equals 4. That's just what our answer is. And then log base 2 of 8 equals what? You're thinking 2 to what power gives me 8? Okay, again, you might know that already, but if you need to, write down the question mark. My base has to match my base. Logs equal exponents. 2 question mark equals 8. What is that number? Well, that is 3. 2 to the third equals 8. If you want to try 4, 5, and 6, you can pause the video and try it. I will try it with you as well. I've got log base 9 of 3 equals what? So 9 to what power gives me 3? You can think, like, if I plug in positive powers, like 1 is 9, 2 would be 81, 3 would be a really big number. So how do I get to 3? You can remember from last chapter that how I get from 9 to 3 is really by taking the square root of 9. But what power is the square root? Okay, if you remember, that is the 1/2 power. Okay. So really, my answer is just 1/2. So I can write the log base 3 of, or log base 9 of 3 is just 1/2. 8 to what power gives you 1? So I put my question mark. 8 to what power gives me 1? I know that any number to the 0 power gives me 1. So I can write log base 8 of 1 is equal to 0. And finally, I've got a fraction thrown in here, so it might be a little weird. 5 to what power? So 5 to what power gives me 1/25? Well, to get a fraction, remember that to flip our number, I've got to have a negative. And then I want to have 5 go to 25. That sounds like I'm squaring. Okay, so if I took 5 to the -2, I would get 1/25. So my answer is just the number -2. So when you're told to evaluate these expressions, again, you're finding exponents. That's your answer because logs are equal to exponents. That's the thing that's on the other side of the equal sign. So it's something to keep in mind of what you're actually finding. There's a couple special logarithms. They're only special because they come up so often that your calculator gave them a button. So a logarithm with base 10, you can think like when things are base 10, we can count them on our fingers. So the base 10 logarithm comes up so much that they call it the common logarithm. This is one of those things where if the base isn't written, you can assume that it's base 10. It's kind of like when you have a square root with no index. You can assume it's just square, or if there's not a 1, or if there's just an x, there's like a 1 in front of it. It's one of those kinds of things. So it's either denoted by log base 10 or just by log. So on your calculator, you should grab that. On the left side there's a button that just says log. That means log base 10. So that's what our common log says right here. Log base 10 of x equals log x. It's just different notation. It's like shorthand. Then the other one, the log base e, is called the natural logarithm. E is a special number. It's kind of like pi. It's like 2.71, and it comes up a lot when we're dealing with logs and exponentials, so we're going to work with it today. So I've got the natural logarithm, log base e. Our shorthand for that is ln. It's kind of strange, so you should probably star this. I can read this as the natural log. So this is something that we can actually do straight on our calculator. So you should grab your calculator and plug this in at the same time as me. Again, on the left side of your calculator, you've got this log button. That's log base 10. And then you have ln. This is the natural log. So the first one on your notes is log 5. All I type in is just log 5, close the parenthesis, and type enter. And let's round this to maybe 3 decimal places. So I've got 0.699 as my answer. I can do the next one. Number 2 is ln of 0.1. So this time we're using the natural log button. So say natural log with me. Natural log. I hope you really said that out loud. And then 0.1. 0.1, close the parenthesis and hit enter. I get -2.303 if I'm rounding to the nearest 3 decimal points. So 2.303 is what I'm writing down. Number 3 is log 7. So I write log 7, close the parenthesis. This should be pretty easy. This is equal to 0.845. And finally, ln 0.25. Close the parenthesis. This is equal to -1.386. So checking back to these notes, if I look at what I just did on the calculator, see how, like number 1 here, I can still rewrite this as my base to my exponent equals my number. So I kind of have like 10 to this power is equal to 5. Kind of looks like a smiley face. But what I really have is another way of writing an exponential, meaning if I take 10 to the 0.699 power, I should get roughly 5. We did round a little bit, so it might not be exactly 5, but it'll be pretty close. Number 2, since we're doing natural log, our base is e, or 2.7-ish. So e to the -2.303 power should be roughly 0.1 or 1/10. And then the same kind of thing with 3 and 4. So it's not a bad idea to check these or rewrite them while you're getting used to it, but that's kind of what's going on here. Looking at the last couple of problems, write an exponential form, log base 5 of 25 equals 2, and then evaluate log base 2 of 28. This is from the beginning of the lesson, so I do want you to try these. I'm going to put a little bit of time on the video and then see how you do. So there are your two answers. Come see me if you have questions on logarithms. I know it's the first time we've done this, so it's a little weird to start thinking in this way. But logs are equal to exponents. The exponent is the thing on the other side of the equal sign. That's the one thing that you can just keep reminding to yourself, keep saying it out loud, and go try some practice problems. I will see you guys later.